Sure, everyone knows about the JVM problem because we're here. So we believe that functional programming is the best way to program. Maybe that's not the case for everyone here, but that's what I definitely believe. The JVM doesn't have a good tool for doing functional programming. For example, Java, if you try and do functional programming in Java, it is possible, you can do it. I have done it professionally. It is a lot of code duplication. And probably I think the first rule of doing a talk is don't alienate your audience, but Scala is not a very good tool for doing functional programming. There's quite a few reasons for that, and I can talk about that, but I don't really want to talk too much about Scala. What I want to say is we don't really have a practical option for doing functional programming, and therefore the JVM may not be a practical option at the moment. So what I think more of a practical option would be something like GHC. GHC has got a really good language for doing functional programming, Haskell. Haskell is quite good at doing functional programming because you don't have the problems that we have in Java, where we have to have code reuse, code duplication. We've got code reuse in Haskell, and we've got a lot of libraries for doing functional programming in Haskell, and GHC can use these libraries. And GHC also has a pretty efficient runtime for executing functional programs. So imagine if we could take GHC and get it running on the JVM. And there was a project called JVM that was done by Rahul Martineni. He was a Haskell Summer of Code student. So the Haskell organization didn't get included into the Google Summer of Code project, so they started their own Haskell Summer of Code, and a lot of people and corporations put their money in to fund students to work on Haskell. And Ed Kmet helped Rahul to work on JVM, and also put in $5 grand of his own money to work on this project. And since then, he had 2 months to do that. 1 month he actually wrote a runtime, and the other month he got Haskell to compile it to bytecode. So he did a very good job in a short amount of time. And since then, he's got a couple of people interested in that, and so he created a company called TypeLead, and so he's hired a couple other people to work with him to try and get Haskell into enterprises. And so since then they've gone through a rebranding called ITA. And if you go onto the website of ITA, it looks something like this. It's a powerful language for building scalable systems on the JVM. If you look all through this, you will not see any reference to Haskell. So they're trying to rebrand Haskell and try and get it into enterprise markets. So one of the examples you saw there was this, which was a game that you can play. I'll see if I can run it. So it looks something. I use Xmonad, so this is half my fault, but also it's got something like this, and we can play a game. And so this is actually Haskell running on the JVM. Okay, so the way this works is that the ITA compiler is just a fork of GHC. What it does is it replaces its GHC's backend, which is usually machine code, with a JVM backend, and then we have to provide a runtime to execute the code that we generate. So there was one person that mentioned GHC.js at the beginning. This is like that, but for the JVM.
Is there any opportunity for merging these three projects?
GHC.js, GHC, and ITA?
Wouldn't that be crazy?
I mean, no. Not really. I don't think so. One of the things that ITA is also going to do is add a lot of extensions to GHC. And so that kind of excludes it, I think. Some of the extensions they want to add, I don't think will be compatible with what GHC will want to do. Also, it's kind of tricky because there's a lot of code that goes into GHC.js and a lot of code that goes into ITA, and it's not very shared for a lot of it. I mean, the whole front end is, GHC itself is, but the back ends are pretty separate.
But the core language is still the same, right?
Yes, and we reuse all that. So it is a fork of GHC, and we do reuse the code. So what you want is a front end that is maintained separately to.
So is the STG the same? Or is it
Let's talk about that. So how GHC compiles is it goes from Haskell to core to STG to C++ to native code, and you can look at each of these by adding flags to dump that. The way EDA works is by replacing the C++ and machine code with just a backend that compiles from STG to bytecode. Yeah. So it does kind of like, I mean, it's a fork, but it does use all the code all the way up to the generating code part. Yeah. So, I mean, it would be good if there was a project there that was separate, that did all of that and said, now you go, like, it would be awesome if my compiler was a function. Compilers kind of suck like that. They're not really functions. They're executables. I hate that. We should have compilers as functions. That'd be awesome. Okay, so when you look at these languages that Haskell goes through, so Haskell goes core, STG, and then a couple other things. If you look at these, Haskell's really convenient to write. It's got some extensions, which is awesome. When you get to core, you know exactly where you're going to evaluate things. So Haskell being a lazy language, evaluation can be tricky to figure out. And when you look at core, you know exactly where it is. There's only one statement in core that tells you when things are going to evaluate. So anytime you see a case statement in core, you know something's going to evaluate. With STG, you've got explicit allocation. Anytime you see let, you know that memory is going to be allocated on your heap.
It's probably worth like explaining those a little.
Okay. No, okay, this is too hard. Don't worry about any of this. Let's just get to demos. No, yeah, no, this is, yeah, let's not worry about that. I mean, basically, Haskell compiles from this to something that looks like this. It's a little bit more code, a little bit more inconvenient to write. There's more explicit things in here of how Haskell executes that you can figure out by looking at this. This is even more explicit about how Haskell executes. Memory gets allocated, you can see that now. There's just more explicitness. And it compiles to stuff. So each of the, so that print function that we saw gets compiled into something that looks like that, and we can compile from this straight into Java code, and it looks very similar. That's basically the point. So one thing, how I'm saying explicit allocation, we actually represent with new. So one thing of how we've got explicit allocation, because we compile down from Haskell to core to STG, whenever you see let in STG, it compiles into new on the Java bytecode. Does that make some sense? A little bit of sense? No? Okay.
It's not a primitive. Where you go through your whole talk in 5 minutes.
Yeah, okay, no.
That's
So
for objects, is it? What does it do for primitives?
for primitives like int, yeah. So, because we have ints that are boxed, this is going to be a boxed int, so we do allocate.
Future allocate, future optimization to
Use the mic.
We do have unboxed integers, which we'll just put an integer in there. Yeah, yeah. So boxed will allocate, and unboxed will just have it. Okay. So yeah, Haskell compiles down to a language. That language is pretty explicit in how we can do things. So once we got into that stage, we can just write an evaluator in Java to evaluate it. Anyway, so if you're using this language, you've gotten past all the implementation details, you want to actually write an EDA program. There's a heap of language extensions. You don't need to worry about these. It makes it possible for us to write this. So we can actually write Haskell code that this is representing file input stream, which everyone's probably familiar with, and we can have inheritance inside of our Haskell code that represents the inheritance in our Java code. So this is using a lot of type level trickery to represent inheritance in Haskell. So here we have we're saying that file input stream extends input stream. Input stream comes from the standard library of EDA. So we can say that file input stream extends input stream. And then when we write a function that takes an input stream, we can actually say any subtype of input stream we accept. So that little arrow is probably something you're probably already familiar with. Doing some Scala, it's subtyping. So we're saying that there's a subtype that there's a type that subtypes input stream, and we can use that in that function. Does that make some sense? So I didn't know this, but Java has like a built-in MIDI sequencer that you can use. So I wrote bindings to that. So
This is kind of the point where like you can't really share this stuff with JSC.js because this is the Java
Yes.
specific point.
Yeah,
We
yeah.
actually have core. your main language features that you really can't represent in anything except the JVM target.
Yeah. All this is very specific. One thing that I think GHC.js has done actually is that they've submitted a pull request to GHC and they actually got accepted where they added this language. So they added JavaScript in there. So there's foreign import JavaScript in GHC, and they do like just so that they don't have to maintain that code. I don't know. So I guess we could put Java in there, but it just gives us like a little bit easier to merge with GHC, I think. So one of the things is that we can say this is, so at new means constructor. So we're giving our, so unlike Scala where Scala figures out what Java code, like we don't have to write code to call into Java, right? With this, we do have to write code to call into Java. So we have to write some code to represent constructors, and we say this is what we want the type signature to look like. That's what it kind of looks like in Java. And so if we go to call this, it'll try and call that. If this doesn't exist, you'll just get a crash.
They all have to be in IO?
There's two monads that you can put it into, IO or Java. There's a Java monad, yeah. There's the Java monad, yeah. I can't remember exactly what it does, but there's the Java monad. It probably does exception. It does exceptions or something probably.
Is it like monad state of not the real world?
Not the real world. I don't know. We can look into that in a minute.
This is a red pill, blue pill situation. We find out on the back end we've been in the monad the whole time.
Yes. So yeah, we're importing a static function. Here we're saying that there's this thing called open. You can see that we're not actually specifying the name of the function. It figures out the name from this side. So we're not actually saying, like you can say interface and then actually give it the whole specification for where you can have the whole qualified name in there. But you can also leave that out and it'll figure it out based on the types here and the name there. Does it make a little bit of sense? Anyway, so we're specifying a function or a method that's on an interface. Okay, so then we can write code like this. Get a sequencer, open it up, get a file, create an input stream from that. Tell the sequencer we want to play a MIDI file, start it, and then we can keep delaying our thread until we're finished playing. So let's do that. I don't have.
I love that your setup is just as weird as mine. Do you see the Wi-Fi menu as well?
Oh, I've got something like this.
Yeah,
Perfect.
Okay, there's muted.
Okay, hang on. Do I have to plug into something? Oh, no.
You go through the thing. It was just muted before.
Oh, okay. I'm also no volume. Okay, here we go. It's playing something. Not through the right audio, but anyway, it's playing something. So. Okay, and it finished. So that's Haskell calling Java code to play a MIDI file because we can. So is running, so it just keeps looping forever, doing nothing until the sequence is finished. Okay, so what if we wanted to go the other direction? We've written some Haskell code, it's awesome, and we want to call it from Java because we're writing Spring Boot or something. We can do something like this. So we're saying that we want to export a class called profunctor hello, and we've got written this function. It does IO. So I think this is where we're using the Java monad. So we can lift IO into the Java monad, and we're returning 100. So the type of this is something like that, I think. No, so yeah, the type of this is Java a int or something like that. And so we can say export it as this though. So we're exporting this method onto the hello class. On Friday we got support for static classes or static methods, but this is just a normal method. And so we can call this from the Scala REPL, for example. And so you can see it's doing the I/O and giving us back an actual int, which is pretty awesome. Okay, so there's a executable called Atlas. It's a Cabal fork. Cabal is our dependency manager, so it's kind of like SVT, but in Haskell. So with Haskell, with JGC Haskell, usually there's a lot of C code. Well, there's C code in the base libraries. Once you get outside of that, it's usually pure Haskell. Any pure Haskell library will work inside of Eda, but anything that calls C, we'll have to write patches for and replace the C calls with Java calls. So we've written like 32 patches, but well, I think we're actually a lot more than that now. When I wrote this like a couple of weeks ago, we had 32 patches, so we can compile quite a few things, and that means that 221 packages now are listed as supported. Supported means it compiles. Not that we can, like, it might crash if we run it, but it compiles. We can actually, so that's under Eda package right here. So if you know anything about Haskell, we've got all of these packages available. And available meaning you can compile them.
Go back up to O.
Which one?
O.
O? And O. We got two.
Optimize.
No.
And pipes.
Pipes. We got pipes. We got pipes. Yeah. Any other Haskell packages people are interested in? We can try installing them. I don't know if it's going to work. The biggest problems, like, so one also thing, so when I said that we can run any Haskell code, that excludes template Haskell. We don't have a template Haskell expander at the moment, so we are probably a month away from having that. Okay, Lens. So this is like 80% of my day job, and we have this, and so 80% of my day job is solved by this library. Monocle is a way is kind of like the Scala library for this, and it gets like 40% in the way of solving my day job, but I want to get 80%. Lens has just got a lot more combinations in it. So performance is the big thing, right? Benchmarks show we're somewhere between like 4 to 10 times. We take 4 to 10 times the execution of JC. We've actually got, every time you submit a pull request or do a commit into Eda, we have benchmarks, so you can actually see all the details. So we also have a lot of easy stuff we can do. So here's like 18 little things that we can do about performance. A lot of them are pretty small and they should deliver pretty big wins. So I think we can get pretty close to the performance of GC, pretty close. For example, someone made this pull request on Friday, and it increased our performance for between like 15 to 30% across all benchmarks. So this is just replacing a stack with a linked list. So if you can do things like that, you can improve Eda's performance a lot. Yeah.
Brian, what's the upper middle on that? Is it GHC or is it faster? What do you think? What do you speculate?
I speculate we won't be able to do very good with the JIT, so I don't think we'll be able to do too much better. Even like, I think you have to write code. I think you have to write JVM code in a particular way to take. He has actually said that he doesn't think that we'll be able to get very good. So.
So the problem is what's known as a megamorphic dispatch.
Exactly. Yeah.
So the real problem. So what Java or the JVM does really well is taking specific like virtual interfaces and then going. Oh, there's only one implementation of that, so I can just like replace all those, inline them effectively, and that's known as monomorphic dispatch. I didn't know there's only a single one of them. Perhaps there's only a couple, or 2 or 3, and then it can do what's polymorphic dispatch, where it'll do effectively like branch prediction. It'll say, well, most of the time you're only calling this particular implementation, and then in the few cases where you're calling something else, it can kind of decompile and do something else. But when everything is, the only interface that you have is function, there are 6 million implementations of function, it actually has to do a complete virtual table lookup and do all of that stuff. So that defeats most of the hotspot inlining techniques. So Scala has the same problem. All of these things, because they're using this very generic single kind of, the one true function interface, they kind of defeat the JVM's ability to do most of its kind of usual sort of tricks to fix that stuff.
Do you generate lambdas?
That's a good question.
So almost, it's actually not the lambdas, it's the invoke dynamic stuff.
Yeah.
The invoke dynamic stuff is the stuff that the JVM can actually use to kind of go, well, in fact, call off to this other thing. And that's where I think it's coming in, like one of the Scala 2.12.3 or 4 or something. There's some of the stuff in 2.12 that where they can do a lot better, and then a bit further along. And it's the same trick that the JVM engineers are doing to make lambdas work fast. So it is related to what they did on JVM to make lambdas work, but it's invoke dynamic. So I would imagine that this would be able to potentially take advantage of that. However, it's probably a little bit further down
Yeah. Pretty much. One of the problems with using invoke dynamic is we want Android support, and at the moment, ideally we'd want Android support. It's not my primary concern, but ideally Android support would be possible, and invoke dynamic is not there on Android yet. Suppose it's coming in the next big version or something, but.
If it was a separate compiler.
Oh yeah, absolutely. Yeah, absolutely. So with the megamorphic thing, this is how code is represented. Everything is a closure. So it's not something I think Hotspot can do very well at, how it is. But I mean, a lot of optimizations in Haskell happen before you even get to the STG stage. Everything happens in core, pretty much. So we still get a lot of optimization. It's just at a different level. Okay, so it's kind of slow. Let's look at some projects. So when I was saying that we need to, how Scala you can call into Java code without having to write anything, you just call into the Java code. One of the employees that works at TypeLead is working on a tool to automatically create Haskell code that binds into your Java code. So it'll take your class files and create Haskell code that will call into it. So that's being worked on. It's the first step was to write a class file parser in Haskell that wasn't bad, and that has been done. So the next step is to just write this tool. Okay. Does anybody know about core NLP? I haven't really heard of it or used it. No, okay. Someone wrote bindings to that, whatever it is.
Natural language processing.
I imagine, yeah. NLP, yeah. Someone wrote bindings to Kafka. Actually, Alexi did, from Kafka to Conduit. So you can use conduits and stream stuff out of Kafka, which is pretty cool. I haven't executed it, hopefully it works. There's bindings to AWS Kinesis. If anyone knows anything about Kinesis, it sucks to use from any other language other than Java because you have to fork out to the JVM. So if you download the AWS Kinesis bindings for Node.js, it'll actually fork off to Java.
It also sucks in Java, but that's...
Well, yeah. So, I mean, yeah. So, so there's bindings to Kinesis that, I don't know, maybe someone spent a while on this, and so hopefully these are pretty good. I've wanted a good Kinesis client because people use Kinesis, and I want to use that. I want to get their data, and I don't want to write Java code to do that. So, so this will be useful to me. It's basically just mechanical writing of bindings, which is not great, but does mean that I'll be able to play around with Kinesis without writing Java. There's bindings to AWS. Yeah, there's been a lot of experiments in here. This one's Kafka, another Kafka client, JDBC, so you can do database things using Haskell. So these are all mechanical again, I think. Yeah, just wrappers around objects and things. So you can do database things in Haskell. So a lot of these bindings actually, like a lot of these bindings from type lead actually came from, I think, from clients, because they are doing consulting for different places, trying to get trying to get Haskell to work for different clients, and one of them needed database access. So a lot of these bindings came from that. This one's pretty cool. This one's a Spark job written in Haskell. So, I mean, there's some weird syntax that they've invented to be able to do Spark things, but yeah, so this is a Spark configuration to get out data, and it actually goes up to a, you actually like create a jar and build it and just submit it to Spark, and it executes, which is pretty cool. Yeah, so these are all just bindings again, mechanical bindings. So hopefully this, the tool that they're making to generate this will make a lot of these projects be basically generated. And this is a really, really cool project. This is to take, so Y is a representation of HTTP requests and responses. And so it's kind of like an abstract library where you don't actually talk about what server you're using or what web framework you're using. It's just a general data structure based approach. So someone is taking this and porting that onto servlet. So you'll be able to write Haskell code that uses basically any framework that uses Y and run it in a servlet. And so there is some code that does things like that. So it just creates responses and can accept requests and do things, and you can embed this into a servlet, which is pretty awesome.
Can you pick the first and go the other way around?
Could you take a servlet and call it from Haskell?
Yeah.
Run it in Warp or
Run a
something?
JSON app, which is actually backed by Spring.
Could we take a Spring app and call it in Haskell? And put it in Yesod?
Yeah.
I guess that might be possible. Yeah. Okay. Yeah. So a couple of things we need to do is write a lot of bindings. Hopefully, the tool that we're going to have will be able to automate a lot of that. We need to port a lot of things from Hackage because some libraries have C code in it. One I did the other day was terminal size. There's a package on Hackage called terminal size, which will tell you how big and small your terminal size is. So I had to pull in JLine and then write some code to do that. So just things like that, finding code that has a little bit of C in it and then swapping out the C for some Java code. And obviously increase the performance, both in the runtime system and also in the generator code that we generate. So there should be places to work on that. There's actually a lot of issues that it's pretty well understood how to improve the performance pretty well. So we should be able to get a lot closer to that, and so hopefully we will pretty soon. Here's a lot of resources. Most of this is about how Haskell executes and how you can figure out how Haskell executes and how you compile it, but that's not very interesting to Scala programs. Sorry. If you're interested in either, there's like a Gitter room that you can join and talk about it and try it out. And then there's this, which has got there's quite a bit of documentation and a lot of questions you have, which is like, why didn't you just contribute back to GHC? Why are you doing what you're doing? What's the commercial implication of either? That's all defined in there. So if you've got questions like that, you can look in the FAQ.
Any questions? All right, Tom.
Is there any reason why I'd use this? Two questions. Is it ready for it to use? I'm going to say production employees. Would you use it in the system? And the second question is, why would I use this over Haskell or unless I had to?
If you don't need the JVM, don't use this. Yeah. Would I use it in production? I probably would, but that's me. Would I recommend you to use it in production? Probably not. That's not saying anything about you, but it's just saying things about how I would work on ITA a lot. if you've got Haskell code that doesn't need many libraries and you just want to have the Haskell code execute, then it will work. It won't be fast, but it will work. Yeah. To write an application that does like web things, which I'm probably assuming you might want to do, yeah, no, that's not going to work. If one thing that could work is if you want to write Haskell and you want to write all Java, like if you want to write bindings, a lot of bindings to like whatever you want, like whatever, like so if you wanted to, let's say you wanted to write a servlet and you wanted to use Haskell, you could do that. But if you wanted to rely on any libraries that do servlet, like do web requests or anything, you're going to run into problems basically. Yeah. So anything that's pure Haskell will work fine. You will probably have to write a lot of bindings if you want to put into production today, because we don't have the libraries around that do that.
Just certain kind of classes of problem. Like say for instance you needed a server resident compiler, you had a bunch of compiler code already written, maybe in Haskell, it's a great FP problem. So then you were like, I just want to put that in. This would be potentially a really good thing, because you want to integrate that into your JVM application. So that might be the kind of thing where you go, right, that's an easy early adoption place for it.
Yeah.
Unless you just really like Haskell and you just stuck on the JVM.
This is really cool. You showed an example with subtype belonging.
Yeah.
And one of the things that's difficult / annoying in Scala is the mixture of parametric polymorphism.
Yeah.
I was just wondering if you had any problems with that and what they were.
Well, it'll only work for FFI basically. Well, yeah, it'll only work for FFI basically. So you have to be explicit about it too. If I just said for all A there, it wouldn't be very useful, because then if you went to actually compile that to Java bytecode, it needs to know more information than what you give it. Like you can't have a for all A there, because what bytecode would it compile into? So it needs to know something about input stream, because that's the actual type signature. So what I could do there is take out this A and just put input stream in there, but then I can only give it input streams. I can't give it any subtype of input streams, right? So, I mean, this is pretty much only useful for FFI, so I haven't run into any problems with it, and I don't think you really could, because I guess you could, because you could get out something that you didn't want to be a subtype or something. But I mean, it's only if you're getting something from FFI and you're giving it to something else that you actually take in subtyping. So if you don't want to fall into any problems with subtyping, do pure Haskell, like take that object and put it into another object that doesn't subtype anything, and so you don't have that problem. Yeah.
Sure, the point this isn't new syntax, this is just type families and type classes.
Yeah. Yeah.
It's a multi-parameter type class called less than colon.
Yeah, like it's not a Haskell extension. It is something that uses a Haskell extension. So it's
powerful enough
to represent it. Exactly. Yeah. Yeah. I mean, this was basically a library. It's not really an extension. The extensions are these extensions, which are all Haskell extensions. So yeah, this magic is kind of coming from just those extensions being used together. So I mean, there is like some magic, and some of those extensions kind of don't do too well together. But in this way, it's pretty good.
But you've never had type inference problems.
Oh no.
The Java and
No, you don't get any type inference problems. Everything's still fully inferred. Like where I exported that. Well, okay. I mean, world here. I haven't given an explicit type from a type of. So I still get lots of type inference. Yeah.
So Java's type system is pretty basic, but Scala's is a much better match for Haskell's. We have polymorphs and we have backend types, so on. A foreign import Scala would be really interesting.
It would be interesting, yeah. And someone wants foreign import Scala and also foreign import implicit, which I don't want to do.
That is in Haskell. So.
Yeah, we do. Yeah, we do actually. Yeah. It would work very differently from how Scala does, so you would probably get the wrong implicit if you did that. It would be cool. If you're in the intersection of people interested in Haskell and also are doing Scala and use Scala at work, you might be using something like Scala Z, and you might want to work with both Haskell and Scala Z. And so, what happens when you have a Scala Z monad and you want to use a
library specific FFI
So yeah, I think it's all too specific. I think if you want to call into Scala, you should just write a Java wrapper for it. It's not great, but I think Scala is too complicated basically for us to use.
I can see that you're probably going to do some unsafe course to get things to work.
Well, there's a couple of features that you want though, like 500 types that would fail in that situation, right? So you want to be able to say, I want to, so this Scala code can implement this Haskell interface by this kind of thing. So there is some value to that.
Oh yeah, there is some. Yeah, I don't know. My impression from looking at it is that it's just pretty complicated, and so it's the value that we get out of it probably isn't worth the effort.
Yeah, I would imagine that for your little world, you'd probably just go no. All of that code goes in.
That's legacy.
In and that code stays in Java.
Yeah, something like that.
If you were to start using Scala type classes, then you probably end up with coherence issues.
Yeah. Oh yeah. Absolutely.
That's just this is not really changing that story.
So this occurs to me, and I bet this has occurred to you. The real competition for this is, okay, I'll just do a native Haskell process, and I'll put a HTTP interface on it, and I'll bridge to the rest of the system, which may be written on the JVM or not. I mean, that must be on your mind.
Oh yeah. Yeah.
You must be tempted to do that often.
Oh yeah. Yeah. I mean, the other way is something like this, which is actually this uses JNI to call from from JVM through to the Haskell code that you write. So it's basically like a thin wrapper that calls into Haskell. So you can actually write Spark jobs in Haskell today without using either. So it's things like that. Yeah.
That's even another idea. But in the spirit of microservices, which are all card-carrying accolades here, you would just say, it's another service. It runs, it's the Haskell.
I personally would even avoid the JVM at all.
Yeah, the other guy's got the JVM problem, and you've
got exactly.
Your Haskell native microservice over
here. Yes, should do that. I agree. If you can avoid the JVM, I think you should really in most cases, because GHC has got a lot better runtime for functional programming. If you're stuck with a manager that says, hey, you need to use Spring Boot for your next application, I want you to do this.
Yeah, there's a political dimension.
Oh yeah. Or if basically you need to use some libraries. I think that's kind of like the only two cases where I would justify using the JVM.